Hello students, today we will see vector form of Newton's law of gravitation or universal law of gravitation. For this, first of all we'll see we are considering here 2-point masses, body, that is A and B. Look at here, this is A and this is B, the means two positions are there and the two bodies of masses M1 and M2 kept here, and they are r distance apart from each other. And here you will see that r12, this r12 is the r12 is the displacement vector which is working in this direction from A to B, and r21 is the displacement vector working in B to A. Okay, here you will see that the this is origin, means the position vector is given. The position vector of mass m1 is r1, position vector of mass m2 is r2, and so that you will find the unit vector, this is r12 cap, is the unit vector from A to B, and r21 is the unit vector, r21 cap is the unit vector from B to A here. Now you will see that as we know, body A means the body of mass m1 will apply the force on body of mass m2, and the body of mass m2 also will apply the force on body of mass m1. If we are representing here F12, that is the gravitational force exerted on body A by body B, and F21 is the gravitational force exerted on body B due to body A. R1, R2 already I said to you, that is the position vector of M1 and M2 respectively, and you know that if just we'll apply the triangular rule, so this is OA plus AB will give us OB here. So OA is R1, AB is R12, and that is equal to R2. That means R12 is equal to R2 minus R1. So R12 is equal to R2 minus R1. Similarly, we can find out R21, that is equal to R1 minus R2, just by applying the triangular rule of addition, vector addition. And we know that this is R12 which is working from A to B, or R21 which is working from B to A. They are different in direction but they are same in magnitude, and that will be equal to R, because the length of this line AB is fixed here. So R12, the magnitude of R12 and magnitude of R21 both are equal, and that will be equal to R. The distance from which these two bodies are kept apart, so that distance is there. And here you will see that obviously you can look at here, R12 and R21 are equal in magnitude but opposite in direction. So we can say these are the two vectors, anti-parallel vectors we can say simply. So R12 is equal to minus R21, we can write in this way. Okay. Now we'll see that according to Newton's law of gravitation, we know that the force of gravitation or gravitational force is directly proportional to the product of masses and inversely proportional to the square of the distance between them. But if we'll show this Newton's law of gravitation in vector form, so first of all we'll see the force F12, the gravitational force exerted on body A by body B, that is F12, that will be equal to G, that is universal gravitation constant, and product of masses m1 and m2 upon the square of the distance between them, that is equal to R, the magnitude of R21 square we have written here, or either you can write R21 or R12, or if you write R then also it would be okay. Okay, but here we have taken because this distance would be there, R21, that is means B is applying force on A, so this is R21. Okay, so that's why we have taken here R21 square. and because we are representing this in the unit vector, so this quantity, this minus g m1 m2 upon r21 square, this will give us the magnitude, but the direction is given here by r1 cap, that is r21 cap, and the negative sign is here. So negative sign is what? The negative sign indicates that the force, the gravitation force, is attractive in nature. Okay, so that's why it is means in vector form we are putting here the negative sign, and this way it will work in this direction. F12 is working in direction R12, and that is opposite of R21, and the negative sign is here. Okay, so you will see that F12, that is the force on the body A by body B, is equal to minus G m1 m2. This is R21 square, already we have written. And now if we'll multiply and divide with this magnitude once again, that is R21, the magnitude of R21 vector, if we are multiplying and dividing with this magnitude, so what we will get here, actually when we are representing any of the vector divided by the magnitude, if any vector is divided by the magnitude, it gives us the unit vector of means it gives us the unit vector. Okay, so here you will see that if the magnitude is multiplied with the unit vector, that will give us the vector here. So here also the same thing you will find, that R21, that is the unit vector, R21 cap is the unit vector multiplied with the R21 magnitude, means the vector R21 magnitude of this. So this will give us vector R21. Okay, now F12 minus G m1 m2, this is vector magnitude of vector R21 square and magnitude R21. So this will be multiply and it gives us cube here. So this is now what? This is the magnitude of vector R21, position vector, sorry, displacement vector R21, and this one, this two quantity, when it is multiplied, it will give us vector R21. So in this way we will represent the force, the gravitational force work on body A due to body B. So this is we'll write in this way, or we can write in this way also, just replacing this quantity, that means the magnitude of vector R21 cube with R cube, because both are equal in magnitude. Already we have seen that. Here you can see that R12, the magnitude of R12 is equal to magnitude of R21 and equal to R. Okay, so that's why we have done here, that means the magnitude of vector R21 cube we have written as R cube. This we say as equation 1. Now similarly you will see that actually we'll see this R21 we can means change with this quantity, which already we have means I have explained to you, that is R21 is R1 minus R2, and here also this R21, this will be also R1 minus R2. So this way also we can represent. So there are means F12 can be represented by this formula also, and by this formula also, and by this formula also. Whatever type of question is there, according to that we can put all these three formula for F12. Okay, now similarly we'll see F21. F21 is what? It is a force, gravitational force exerted on body B by body A. Now similarly as we have seen for F12, the same way the magnitude would be same here, like G m1 m2, because universal gravitation constant is there, product of masses would be there, and the distance between them, the square of the distance between them. So this here we have written R12, magnitude of R12, and as we have written here R12 cube, and this we can write as R12, means the vector R12 as we have written here for the this equation. Okay, for F12. So similarly we can write in this way. Now you will see that this formula, the F21, that means the force on body B by body A, that can be represented by this formula also, minus g m1 m2 upon, in place of r12, the means magnitude of vector r12, it is same as r here, so this will be magnitude of r12 cube is replaced with r cube and r12 here. So this is equation 2, or otherwise we can write in this way also, that is f21 equal to minus g m1 m2 upon, this is r12, the displacement vector is given by the difference of the position vector r2 minus r1. So we'll replace here r2 minus r1, the magnitude of the vector r2 minus r1 cube here, and here also we can write r2 minus r1, okay, in place of r12. So this way, now you will see the equation 1 and equation 2. If you carefully watch it, what you will find, that is f12 and f21, the quantity minus g m1 m2, this is also m1 m2, r cube, this is also r cube. So this will give us the magnitude, this will give us what, the magnitude. And we know that the magnitude of r21 and r12 are same, only the direction is different and they are in the opposite direction as we have seen in the figure, okay. So that is, these two are different in direction. So what we conclude here from equation 1 and equation 2, that is the force 1 means gravitational force 1 2, that is equal to minus gravitational force f21, or what you can say, that the gravitational force exerted on body A by body B is equal in magnitude of the gravitational force exerted on body B by body A, but different in direction. Both are working in opposite direction. Thus, the gravitational forces between two bodies are equal in magnitude and opposite in direction. And these are the means these three equations, which already explained to you, can be applied for any of the numerical or for to find out the gravitational force between the two bodies in vector form. Now example 8.2, and this is very important example given here. The question given here is 3 equal masses of m kg each are fixed at the vertices of an equilateral triangle ABC. You can see that this is the equilateral triangle ABC, and 3 masses of means identical mass of m kg, that is here also m kg, here also m kg, and here also m kg. These 3 masses are kept in the vertices of this an equilateral triangle. This is an equilateral triangle, so all the angles means each angle of this triangle is equal to 60 degree, okay. And we'll find here what is the force acting on masses 2m placed at the centroid G of the triangle. Now if you just draw the altitude from the vertices, you will find where this altitude will intersect. That point will be centroid, and the centroid is located here with G, and here another mass is kept, that is of 2m. Now we have to find out that what is the force acting on the mass 2m. So the force acting on mass 2m can be the vector sum of the force acting on means due to the force kept at point A, at B, and at C. That is equal to what? If we'll suppose the force which is working at G, that means at 2m is equal to F. So the F must be what? If we are just saying that is this force is working at 2m, so F must be the vector sum of Fa plus Fb plus Fc. And what is this? The Fa is the force. Fa is the force due to mass m, which is kept at point A, and Fb is the force due to mass m kept at the point B, and Fc is the force on 2m due to the mass m kept at point C. Okay, so this way we'll find here the force, the magnitude of the force. We can means the vector sum of this will give us the force here. And what is the force if the mass of the vertex A is double? So first of all, we'll see the A part, and B part is saying here what means how the force will be changed if in place of this M, if we keep here 2M. Okay, and another instruction is given here, that is AG, BG and CG all equal to 1 meter. That means AG, BG and CG all are equal to 1 meter. So first of all, what we will see here, before finding out solution, we see that the means the points, the force between these two, A and G. If we see the force between AG, here the mass is M, here it is 2M, and AG is given here, that is 1 meter. Okay. Similarly, you will find the force between BG. So here mass 2M and this is M, and the distance between them is also 1 meter. Now the force between this GC, if we'll see, so that is also here 2M and here M, and the distance between them is 1 meter. So what we can find out here, we'll find out all these forces FA, FB, FC must be equal in magnitude, because these are the product of, because the gravitation force is the product of masses, and product of masses divided by square of distance between them. So these quantities are same for each one, means the mass kept at A, B and C. So FA, FB, FC must be equal. So what we can say, this is FA equal to FB equal to FC, and suppose this I am writing as F dash, suppose. Okay, this is equal to F dash. So in such situation, you will see all are equal in magnitude. And what is F dash here? The F dash must be equal to G, universal gravitation constant, mass 1 M, mass 2 2M, and distance between them, that is 1 meter square. 1 meter square. So the F dash is what? It is 2 GM square, and 1 meter square, square of 1 meter is 1 only. So this will be F dash is equal to 2 GM square. This will be the magnitude. Now we'll find out the direction, because we have to represent this in the vector form. So just to represent the gravitational force in the vector form, we need the direction. To find out the direction, first of all, you will see here, look at here, this is FA. FA is working in y direction, means if you see that this G point is origin, so if G point is origin, a horizontal line here which is passing through G is representing the x-axis, and this vertical line is representing the y-axis. Now you will see that this is the FA is working towards the positive y-axis. So if we'll just write FA, we'll see FA. So FA can be written as the magnitude F dash. This is the magnitude F dash, and because it is working in positive y direction, we'll write J cap. That is J cap is the unit vector in positive y direction. So this is F dash J cap will be the vector representation of FA. Now look at here for the B, that is FB. If we are looking for FB, what we'll find here, this is, as we have seen that this point, that means this GB is the angle bisector here. So the whole angle, that angle B is 60 degree. So this will be 30. If it is 30, this is also 30. Okay. Now if it is 30 here, because Z is there, alternate angles are there, so it is 30 here. So a vector which is working in direction GB, look at here, the vector which is working in direction GB, that is the vector FB. That means we can resolve in two component this is one component and this one will be another component. Okay, so this component is the component can be written as the cos theta term. So I am just writing the component here, that is f dash. That means this fb is what it is, the f dash is working here. So f dash cos 30, we can write this f dash cos 30, and this component is then f dash sin 30. Okay, now this GB, the force which is represented through GB, can be written as the sum of these two vectors. So that can be written as what? That is f dash cos 30 degree, but you can see that it is represented in negative x direction. So negative x direction, the vector will be, the unit vector is I cap, but it is in negative, minus I cap. We can representing minus I cap. Okay, and here you will see this one, this is in the negative y direction. So it is negative y direction. So we can write this also as minus j cap, just multiplying with minus j cap. That means it is what? Minus f dash sine 30 j cap. So this force FB, which is working towards G to B, is represented as sum of the two vector, that is G vector sum of this GA, the force working in the direction Gx dash and Gy dash. Okay, so we can write in this way. Now you will see just for this FC. So what is FC here? FC is the force which is working towards G to C, and you will find that once again this would be 30. If it is 30, this is also 30. Then once again this FC we can resolve in two component. Here also we'll see this is f dash, this one is f dash FC, which is equal to f dash. So f dash cos 30, and in this direction once again we'll see f dash sin 30, f dash sin 30, or whether you can write FC also, then also no problem. For your simplification means you can understand it well, I can write this like this FB, this can be FB and this can be also FB, and here also I am writing FC here. This is FB and this is FC and this is also FB. Okay, so this can be written as, you can see that it is in positive x direction, so it is FC cos 30, FC cos 30 I cap, and minus what we can write this, this is in once again the same way as it is written here, the second term. So that way also we can write here FC sin 30 j cap. Okay, now we can see here the force on mass 2m will be vector sum of all this. So if it is vector sum of all this, will take total force or the net force which is working, net force on 2m, that is sum of FA plus FB plus FC. Okay, the vector sum of these forces. Then it is what, this also I am just writing FA for simplification, that is FAJ cap minus FB cos 30 I cap minus FB sin 30 j cap, then plus FC cos 30 I cap minus FC sin 30 j cap. Okay, now we know that FA, FB, FC all is represented with F dash. So once again I am writing F dash j, that is F dash cos 30 I cap minus F dash sin 30 j cap plus F dash cos 30 I cap minus F dash sin 30 j cap. Now what you will find here, these two quantity, this one is positive and one is negative, so this would be cancel out each other. Then remaining is what here, that is F dash j minus these two will sum up, that is 2F dash sin 30 j. Okay, now we know that the value of sin 30 is 1 upon 2, so it is F dash j cap minus 2 would be cancelled, this is F dash j cap. So one is positive, another is negative, then it will be 0, cancelled out. Then the total force or the net force at point G or at centroid or on mass 2m will be 0 here. This is the part A. This is what? This is A part of the question. Now we will see the B part of the question. In this we will see in B part of the question. The question was that if we just change this the mass at point A and will keep it double, that means it will be 2m. So the similar way you will find here, if it is double, then what happened? You will find the FA, what you will find, this is FA will be double and that will be equal to 2F dash, that will be equal to 2F dash, and rest of the quantity is same, that means FB and FC. If we talk here, FB and FC, that is equal to F dash only, that is equal to F dash only, and where we have taken out F dash as what? F dash we have taken out, that is equal to 2gm square. Okay, so will not write all the things again because FB and FC is as already it is indicated, that way we have indicated here F dash this FB. Okay, so here we will write now the same thing as it is for the net force. So you will find the net force. Now the net force on 2m at centroid, that will be the vector sum of FA plus FB plus FC. Now what you will find, FA is this time it is what? It is 2F dash, and which is working in which direction? It is working in this positive direction, so J cap here. Okay, now the rest of the quantity, if we talk about FB, so FB is what? FB is F dash cos 30 I cap minus F dash sin 30 j cap. Now FC is what? FC is plus F dash cos 30 I cap and minus F dash sin 30 j cap. Okay, now we'll see that 2F dash j cap, this 2 will be cancelled here, this is 2F dash sin 30 j cap. Okay, and 2f dash j cap minus this is 2f dash sine 30 is 1 upon 2 and 2 would be cancelled. So 2f dash j cap minus f dash j cap, that give us f dash j cap. And what is f dash? We have taken out the magnitude f dash, and that is equal to 2gm square j cap. So this would be the force, this would be the net force at point G centroid when we replace the mass at point A, or when we double the mass of point A. Okay. Gravity is the force of attraction exerted by earth towards its center on a body lying on or near the surface of earth. Gravity is merely a special case of gravitation and is also called Earth's gravitational pull. That means gravity is the force of attraction exerted by Earth. Actually, the force of attraction between any two bodies will be there, that is called the gravitational force. But the force of attraction between a body and the Earth, that is called gravity. So gravity is what? Gravity is a specific case of gravitation in which one body must be Earth here, okay, and is also called Earth's gravitational pull. So that's why the Earth's gravitational pull is called gravity, because one of the body must be Earth. Now, acceleration due to gravity. Acceleration due to gravity, it is defined as the constant acceleration. Acceleration, we know that the change in velocity with respect to time, whether the velocity will increase or decrease. So both the cases are called the acceleration. If the velocity will increase with respect to time, that is called positive acceleration or simple acceleration. And when the velocity will decrease with respect to time, that is called retardation or the negative acceleration. So here the acceleration which is produced in a body when it falls freely under the effect of gravity alone. That means just now we have learned about the gravity. Gravity is a specific case of the gravitational pull in which one body must be Earth. So whenever Earth is attracting any of the body, in such case the body is moving towards the center of the Earth with some acceleration, and that acceleration is the constant acceleration, and this constant acceleration is called the acceleration due to gravity. It is denoted by G, and the SI unit of G, that is small g, is meter per second square, as we are already taking for the acceleration, that is meter per second square. And dimension formula is m0 lt minus 2. It is a vector quantity. Obviously, whenever the body is falling towards the center of the Earth, that time we are taking it positive acceleration, and when it is going away from the center of Earth, in such situation we are taking it negative acceleration, that means minus g. So it is a vector quantity, and g depends on mass and radius of Earth or the planet due to which there is a gravitational pull, because already we have seen there is a gravitational force is the universal gravitational force. That means it work between any two bodies, whether it is heavenly bodies or small bodies, whatever, but any two bodies in the universe, the force which is attracting force between the two bodies are called the gravitational force. So if we are talking about the acceleration due to gravity in case of Earth, it depends on the mass and radius of Earth, and if you are taking the acceleration due to gravity for any other planet or for any heavenly bodies, in such situation that g, the acceleration due to gravity, will will depend on the mass of that planet or the heavenly body and the radius of that planet or heavenly body. Okay, so this is about the acceleration due to gravity. Now we'll see relation between capital G and small g. Capital G is the universal gravitation constant, and small g is to represent the acceleration due to gravity. Now to find out the relation between these two, we'll see here, consider the mass m of earth, sorry, consider the mass of earth, capital M here. You will see this is the earth, and the mass of the earth we have represented here with the capital M, and the radius of earth is capital R. Body is kept, whether you will say on the surface of the earth or near to the surface of the earth. So this is the mass of that body is small m, and then according to Newton's law of gravitation, the force of attraction, the gravitation force of attraction will work between these two, the center of these two. Okay, so you will find here this will be equal to F g mm upon r square, where g is the universal gravitation constant, m is the mass of earth, small m is the mass of the body, and r is the radius of the earth. Because you can see here, whenever we are taking the distance always taken between the center of the two bodies, means the where the center join, that center of the two bodies. So here you will see the radius of the earth is very large in comparison to the radius of the mass of that body. So we can omit that radius of the mass of the body. Simply we can say the distance between these two will be equal to r, capital R, which is the radius of the earth here, because the body is kept on the surface of the earth. So this is r, and in such case it is r square. Now we can see that the body, this earth is pulling the body towards its center, and that is called the gravitational pull, and that is also equal to the weight of the body, as we have seen in case of the laws of motion and the Newton's second law of motion. In that case we have seen that the force between the body or the gravitational pull, whatever it is, the force is equal to mass into acceleration. So the gravitational pull by which the earth is attracting to it, that is called what, the force, that is equal to mg. So here you will see this is equation 1 and this is equation 2. Now if we just check the equation 1 and 2, this is gravitational force, and the gravitational pull is also a gravitational force between these two bodies. So these two forces will be same here. So the left hand side value is same, so the right hand side values must be same. So we have written the right hand side value of equation 1 and 2 as mg is equal to g mm upon r square. Now you will see that this m and this m will be cancelled, and g is equal to gm upon r square. So from this you will find that in this equation of the acceleration due to gravity, the universal gravitation constant is there, and this is the constant only, no variation in this. So the g will be vary according to the mass of the planet or the mass of the heavenly body, or the radius of that planet or the radius of that heavenly body. Just before this derivation, we have learned that acceleration due to gravity depends on the mass and the radius of that heavenly body for which we are the acceleration produce. Okay, so here you will see that the acceleration due to gravity, g is independent of mass, shape and size of the body in which it produce. That means the acceleration due to gravity जिस बॉडी में प्रोड्यूस होता है उसके मास, शेप और साइज से पे डिपेंड नहीं करता, लेकिन जिसके कारण प्रोड्यूस हो रहा है, मीन्स द फैक्टर, और you can say for what planet or for what heavenly bodies it is producing, for the mass of that body and the radius of that body, it depend on that mass of that body and the radius of that body. पर जिस पे प्रोड्यूस हो रहा है उसके मास, शेप और साइज पर डिपेंड नहीं करता है. ओके, सो दिस इज एक्सीलरेशन ड्यू टू ग्रेविटी. Now we'll see the calculation of g, capital G, that is the universal gravitation constant. Here we'll see, before this we have derived the formula for the acceleration due to gravity, that is g is equal to gm upon r square, where in case of the acceleration due to gravity, that is, this is G is the universal gravitation constant, m is the mass of the earth, and r is the radius of the earth. Now if we have to calculate capital G, in such case we'll utilize this formula in this manner. The r square will go here, so gr square, and m will be go down, that is gr square upon m, and that will be equal to capital G. So we'll use this formula. The capital G is equal to gr square upon m, and here the small g, the value of a small g, that is the acceleration due to gravity, is equal to 9.8 meter per second square. Now the r, radius of the earth, is 6400 kilometer, or in meter if we'll represent, it is 6.4 into 10 to the power 6 meter. Now the mass of the earth is 6 into 10 to the power 24 kg, and if we'll put all this value in this equation, capital G is equal to small g, r square upon m. So the 9.8 into 6.4 into 10 to the power 6, the whole square, upon 6 into 10 to the power 24. So if we'll simplify this, the value will come 6.67 into 10 to the power minus 11, and already we have seen the SI unit of universal gravitation constant, that is equal to Newton meter square per kg square. So the value is 6.67 into 10 to the power minus 11 Newton meter square per kg square.